Hey guys, so I'm using this video to kind of walk you through Module 5 quiz and kind of explain how to apply the equations for odds ratio, absolute risk reduction, relative risk reduction, and number needed to treat, as well as effect size. So some of the things that we talk about that are used for interpreting results in therapy studies, looking at dichotomous data. A lot of this information is based out of your book, and for the equations, you can use the Interpreting Risk and Ratios in Therapy Trials PDF that I provided you in class as like a go-to guide. I've also provided you with a PowerPoint that kind of explains. It just gives you the basis. I didn't make a video because I thought the video for this quiz would be more substantial to you than me posting a video on the actual lecture. So if you want a little more background information, look at the PowerPoint. But this should pretty much explain how to use those equations that you saw in the Module 5 quiz and essentially what they mean. So I have up two screens here, and I'm going to kind of walk you through the quiz to explain to you and use this as kind of like of a guide, and hopefully this will make more sense to you. Also check out the PowerPoint. It does give you some good amount of information that might be useful. Alright, so let's get started. So we have the Module 5 quiz that we took, and the first set of data said you are working at a local high school when the athletic director reaches out and asks for your help. Last season, the school set an all-time record with knee injuries to female athletes. Knowing that you have a background in rehabilitation and functional movement, the athletic director asked if you would develop a training program to try and avoid knee injuries in the future. You mentioned that it would be great to do an experiment to see if the program works. You randomly assign female athletes to either a no treatment or a treatment group. At the end, you collect the data, which is listed below. So let's talk a little bit first and foremost about this little graph that you see here. This is a 2 by 2 contingency graph. This is table. This table you will see in all therapy trials, and it's used to help you calculate relative risk odds ratio, absolute risk reduction, relative risk reduction, all of those sorts. This table is important. You should know what this table looks like when you see it in an article. And it's pretty basic. You have your groups, you have your control group and your intervention group, and you have your non-exposed and your exposed. And if you want to relate that back, you can look at the PowerPoint that I gave you, and this essentially is what it is. You have an exposed group and an unexposed group, and you have a control group and a case control group. And of those both, or of each group, you'll have exposed members and unexposed members. We label these A, B, C, D. These letters are your calculations to everything that you need. So know when you see a contingency table, this is what it's going to look like. It's going to be A, B, C, D. Now let's look at our quiz, and it's essentially the same thing, okay? So I put it over here in this Word document to see if you can follow me a little better as I walk you through it. And I've put here, this is A, this is B, this is C, then this is D. So let's walk through the questions. The first one says, what is the absolute risk reduction of your program? We know that absolute risk reduction is the difference between the absolute risk of an event in the intervention group, that's this one, and the absolute risk in the control group. And what we use to calculate this is CER minus EER. Now, what does that mean? That means control event rate minus experimental event rate. So, what is the rate of events of that happening in each group? Experimental is the same thing as saying cases, or is the same thing as calling it intervention. However you want to look at it. It's the experimental group that you're comparing it to. To calculate that, you're going to use, this is the equation. So this C divided by C plus D is for control group, and this A divided by A plus B is the experimental group. That's this. Okay? Now, that's based off these boxes here, this A, B, C, D. So I will do it for you here just so you can kind of see. So again, the question asks us, what is the absolute risk reduction of your program? Essentially, calculate the absolute risk of reduction. So let's do that. And as you can see, I already wrote the answers here, but let's walk through it. So we need to know the control event rate. So we use C divided by C plus D. C divided by C plus D. So we have 90 divided by 90 plus 9. Okay? That gets you 0.909, and I'm just rounding to the third number, okay? Now we need to take the experimental event rate. The equation for that is A divided by A plus B. So A is 95 divided by 95 plus 3. So we're going to have A 95 divided by 95 plus 3. And for that, the answer is 0.969, okay? So now that you have the two, all you need to do is subtract them, because that's essentially what it is. I'm just breaking it apart so that you can see it. So you have 0.909 minus 0.969. The answer is negative 0.06. So this can either be looked at as negative 0.06 or 0.6, or if we times it by 100, 6%. Okay? Any of those answers would have worked. 6%, not, it can't be negative. Well, so 6% or negative 0.6 or 0.6. Any of these three would have worked for an answer. This equation doesn't change. These boxes never change. So when you're asked to calculate absolute risk reduction, this is essentially what you are calculating. Okay? Now, let's keep going. The second part of the question says, what is the relative risk reduction of your program? Essentially, what is the relative risk reduction? Well, we just need to calculate it. And we know that relative risk is essentially risk ratio. It is the risk of an event in the experimental group divided by that in the control group. So, what you would do here is use, since technically we already calculated most of it, you just need to use those numbers. You're going to use CER, which is control event rate again, minus EER rate. So essentially absolute rate reduction, how we calculate absolute risk reduction, divided by the CER. So in this case, let's do it. And I'm not going to do them all. I'm just trying to walk you through some of them so you can see what the calculation looks like. So we know that CER is 0.909 minus 0.969, which we technically already know is negative 0.06. Now we just need to divide it by 9.09. So let's do that. 0.909 minus 0.969. 0.969 divided by 0.909. Nope, sorry. You have to specify. So let's do it over. That's my fault. 9.9, I'm sorry, 0.909 minus 0.969. And that happened because, of course, I didn't put my parentheses. And you have to use your parentheses. So let's just do it this way. We have, again, negative 0.06, the answer that we got for our absolute risk reduction. And we're going to take that and divide it by 0.909. And we get negative 0.066. Otherwise, if we multiply by 100, 6.6%. So your relative risk reduction, which is again the risk of an event in the experimental group divided by that in the control group, this is just risk ratio, the ratio of this risk, would be 6.6%. That is all you have to do to calculate it. Get familiar with only seeing abbreviations, okay, because you will see that a lot in therapy trials. And these are examples of therapy trials that are using this 2x2 contingency table where you're looking at odds ratio, relative risk, and that sort. Alright, so the next question asks, how many female athletes would you need to treat to avoid one additional injury? This is the same thing as saying what is the number needed to treat. The number needed to treat is essentially knowing how many people need to be in this trial, need to be treated in this trial before one bad outcome happens, or otherwise known as an adverse event. That's what we call a bad outcome. So, to calculate the number needed to treat, you are simply going to do 1 divided by ARR. Okay? So this is 1 divided by absolute risk reduction. To get this answer here, we would just simply do 1 divided by our absolute risk reduction, which we already calculated as to be negative, negative 0.06 or 0.6 or 0.06, whichever, and you get 16.6. The 16.6 is what you should have wrote, or you could have rounded it up to 17. Again, these equations don't change. So when you see the table and you see these type of questions, all you have to do is plug in those exact same equations, okay? All right, let's keep going. So next we're asking what are the odds of having an injury happen in a control group compared to the treatment group. As we know, odds ratio is the odds are the number of times an event happens divided by the number of times it does not within a group. Odds can be expressed as the risk or probability of an event occurring over the risk of an event not occurring. So essentially a good example of that would be 1 divided by, or 1/5 of the patients in the study suffer from a stroke. So the odds of this happening would be 1/5 divided by 4/5, because you have only 1/5 of the population that does suffer from a stroke and 4/5 that doesn't. But let's apply that to what we're looking at here. So to calculate odds ratio, you would simply do A divided by C divided by B divided by D. Sorry. Okay. Again, all based off these 4 letters. So if we apply that, that's just 95 divided by 90 divided by 3 divided by 9. So to see that, if we look using a calculator, I'm just going to put the equations in. So 95 divided by 90, that's divided by 3 divided by 9. Okay? That's our equation. That's what it looks like. We get 3.167. So 6 continuing, or simply 3.17, which essentially means 3 to 1 ratio. So it's 3 to 1. That is the odds ratio. 3 to 1 is the odds. 3 times to 1 of it happening. Again, these equations don't change, so it's just a plugging in the numbers. When you see the question, know the equation so that you can just plug in A, B, C, D. Regardless of the table, you should be able to use A, B, C, D and just plug those numbers into the equations to get these answers. You just need to know which equation goes with which question. Alright, so now that we've calculated the odds of something happening, we want to briefly summarize what this means. So essentially, now that you've calculated the relative risk reduction and you've also calculated the absolute risk reduction, and then you've also calculated the odds ratio, well, after having done all of this, what does this mean? Okay. Essentially, it means that there is a difference between the group and that the effect or magnitude of the treatment is large. And that's based off what we got. Look at this. We have absolute risk reduction of 6%, and we have a relative risk reduction of 6.6%. Okay? Now, if you apply this to our effect size, we mentioned that effect size is 0.01 is low, 0.05 is moderate, large enough, and that 0.08 is very high. So, having calculated this, we can say that there is a large effect size. Now, let's keep going. And let's talk about the second set. So, within the second set, you are calculating the difference between the groups as well as the effect size, and you're briefly summarizing what all of this means again. So pretty kind of similar to what we did before, but looking at a couple different things. So the first question is there a difference between the two groups as it relates to functional movement scores? The answer is there is a difference between there is a difference between the two groups as it relates to functional movement and score. So essentially just yes. And to calculate the effect size, we would use Cohen's d. And the reasons why is because we know that we are using a t-test. And we know how to calculate Cohen's d, okay? So we know that Cohen's d used for t-test, right? And that is essentially mean 1, or mean of control group, minus mean of experimental group or intervention. Sorry, I'm used to saying intervention. Divided by the standard deviation of control group. Okay, that's all it is. When you calculate these things, you can double check your calculations. There are a lot of great calculators out there. So I'm just going to show you an example of one. to show you that you got your answer right. I'm just going to plug the numbers in here. So mean of group 1 is the control group. So I'm going to plug in 95. Essentially, this is A, B, C, D. Okay? And to just kind of show you, I'll go back. Okay, so we have mean 1, mean of group 1, mean of group 2, the standard deviation of group 1, and then we also have the standard deviation of group 2. And we are provided with that information here. So I'm just going to copy this over. Oh, ignore my comment about this is A, B, C, D. Sorry, I did not mean to say that. I'm just going to copy this chart so we can see the numbers. So we have the means of both groups. Let's push this over. Oh, we can't, huh? So no, this is group 1. Oh, it's still going to do it. Okay, so we know this is G1. This is G2 based off our quiz, only because I just wanted to put it over here so we can see it so I can show you the calculator. So here's the calculator. So I'm plugging it in. This is group 1. We have 8.38. We have 9.94. We have a standard deviation of 1.48. And we have a second standard deviation of 1.19. If we calculate that, that comes out to 1.67. This is the effect size using Cohen's d. Okay, now this is just one example. Now I'm also going to show you using the calculator. We would take 8.38 minus 9.94, okay, divided by 1.48. And I'm probably did not have my parentheses right, so I'm going to split it up. So 8.38 minus 9.94. Sorry, 8.38 minus 9.94. It's negative 1.56. Now we're going to divide that by the standard deviation of the control group. That's 1.48. So divided by 1.48, and we get the same thing. Okay, you round this up and you get 1.16. This just isn't rounded. But this answer is the same thing as here. This calculator does the rounding for you. Okay? So if you ever want to check your work and what you're doing, don't be afraid to use a calculator that will help you get there. Or if you're just, if you want a quicker option, this is an option too. But knowing the calculation, it's important. But yes, there are calculators out there to help you if you do need it. Alright, so now that we've calculated the effect size, we came up with 1.6. That's the effect size. Now, essentially we want to know, well, what does that mean? Which is the very last question. So briefly summarize what all of that means. And by this time it should be pretty clear after having done the calculations, okay? So essentially the point that I want you to make, or I would have wanted you to make, was to note that there is a difference between the groups and that the effect or magnitude of the treatment is large. So pretty much the same thing as what we were looking at. What we were looking at for the first set. It's just done a little differently. So this kind of wraps up Module 5 quiz. You will be given a new quiz to retake, but the point to take from this is that even though you may get a new quiz, the application is the same. You will get a 2x2 contingency table. It will look like this, just with new numbers. This will always be A, this will always be B, this will always be C, this will always be D. So when you see the questions, just take the statistical part and automatically think calculation. So if you see absolute risk reduction, know you need to calculate absolute risk reduction. If you see relative risk reduction, you need to calculate relative risk reduction. If you see something that says how many athletes would you need to treat to avoid one additional injury, know that that's the same thing as saying number needed to treat, because number needed to treat is the total number of individuals in a treatment group to avoid one bad outcome or one adverse event. And always think when you're looking at a results section of a therapy trial or any research, what did those statistics that you just read mean? So essentially what we've been practicing. This is just giving you an overview of how to calculate risk ratios and that sort. Another thing to take from this is sometimes if you feel like you need to double check your information, know that there are some decent calculators out there that might be useful for you. So this is pretty much the end of this video. If you guys feel like you need more practice after having looked at the PowerPoint and having reviewed this quiz, let me know. And I will provide a few more practice problems for you. But again, remember, that 2x2 contingency table doesn't change and neither does the equations, only the numbers.